Please title these notes Derivatives 1 Notes, Prerequisite Algebra. By the end of this lesson, you should be able to do the algebraic manipulations that are necessary for taking basic derivatives. The first thing that we're going to review is simply writing expressions with negative exponents. Let's take the expression 2 over x to the fifth. A lot of the time during this unit, we're not going to want to have this fraction bar here when working with an expression. We're going to want to have just a plain old exponent. And so we just need to be able to take this. Remember that a negative exponent is the same as 1 over something to that exponent. So this can also be written as 2 times x to the negative fifth. That's it. Same idea with something like this. Four over 5x cubed. Notice that this negative exponent this exponent of 3 only applies to this x to the third right here. So that's the only thing that has the negative exponent. The 4/5 is just along for the ride. It's going to be okay if we have a fraction here because this is a number, just like 1 or 2 or 1/2 or whatever, but we would like our variables to not be in the denominator. Write that with a negative exponent there. Do remember one of the rules in terms of parentheses. So this that we wrote right up here is different than this. Here the cubed applies to the 5 as well. So this 4 stays put in the numerator, but this whole 5x has that negative exponent. We should also be able to rewrite expressions without a radical. Let's rewrite the 5th root of x squared. The really important thing to remember the 8th root of x to the b is the same as x to the b over a. Notice that we've got this one on the outside that's going on the bottom. This one on the inside is going on the top. And likewise, if we have the 8th root of x and that whole quantity is to the b, still the same thing. The a is going to go on the bottom and the b on the top. Actually, let's go up here and write ourselves a little general reminder for this one as well. If we've got a over x to the b, that a stays in place. That b is just a negative exponent if we write it in the numerator instead of the denominator. Okay, so let's come back over here. We're just going to use this rule. The little number in front of the root goes in the denominator. This goes in the numerator, right like that. Sometimes there are invisible numbers. Remember, if there's no number out here, this is just the square root. There's an invisible 2. And anything to the first power is just itself, so if we don't have an exponent, that's the same as x to the first power. So using that same rule, x to the 1/2. We can also do this if we have a radical in the denominator. I can do the same rule that we had right here. Notice that this x is in the denominator. Why don't we do what we did up here and bring it up into the numerator, because we're going to need that when we work with it later. Right like that. There's nothing wrong with how any of these are initially written. It's not something that would be wrong in a final answer. The reason that we're practicing this is just that we're going to want to have the expression in this form with x in the numerator as an exponent, not a radical, not the denominator, for the derivative work that we're going to be doing later on in this unit. And I found in previous years that a lot of students have forgotten these, and it's easier if we review them now rather than having them trip you up later. Another thing that it's not wrong how it's written, but the convention is that we're going to write it in a very particular way, is that when you get to a final answer, you're going to simplify. And simplify has a very specific meaning. Typically, if you see anything added, subtracted, multiplied, or divided, actually, by a rational function. So a rational function is something like 3 over 4x or something like that. It's just got that fraction bar. You will write it as a single rational expression. So that means, for example, let's say that we had 3x plus 2 over 5x. We're going to write this as a single rational expression, so that means we're going to need to get common denominators first in order to add this up. So this is 3x over 1, so 5x is going to be our giant 1. Five x times 3x is 15x squared over 5x plus 2 over 5x. And now we can add the numerators. Right like that. And again, this is not a wrong way to leave it, but when you're doing multiple choice answers for AP tests, it's generally going to be written in this form, and you need to be able to get from here to here. You need to be able to do the same thing with radicals. In calculus, unlike in pre-calculus, square roots in the bottom is okay, but we're typically going to want to write this as one rational expression rather than two different things. So x square root of x plus 3 is our denominator. It's going to be our common denominator. Notice that square root of x plus 3 times square root of x plus 3 is square root of x plus 3 squared. So that square root is going to go away. These are canceling out in a sense. Notice that since we can distribute this negative, we should. Just so that we can write it a little bit simpler, 1 minus 3, negative 2. Right, like that. Again, now that we're doing calculus, square root in denominator is okay. We want to do similar simplifications when there's division. So let's say we start with 6x plus 1 over 3x, 5x over 7. Remember, dividing by a fraction is the same as multiplying by the reciprocal. So this is 6x plus 1 over 3x times 7 over 5x. If we multiply the numerator, multiply the denominator, 6 times 7 is 42x plus 1 times 7. Three x times 5x, 15x squared. We can also do the same idea with very complicated rational expressions. So let's take this one for example. We've got 3x squared over 5 plus 2x. That's all over the sign of x, which is just a function like any other. We can just multiply, do whatever, just like normal. So we know that this is 2x over 1. Our common denominator is going to be 5. Don't forget to carry the other part down here. You don't want to lose part of it. So we've got 3x squared. Common denominator is going to be 5. 2x times 5 is 10x. All of this is over sine x. At this point I have one fraction in the numerator, one fraction in the denominator. So I'm going to write this as sine x over 1 because I know that if I divide by a fraction that's the same as multiplying by the reciprocal. So it's really 3x squared plus 10x over 5 times 1 over sine x. These can just be multiplied together. Down in the denominator here, these can just be multiplied together. Voila. Typically, if you see anything that can be factored, do it. So let's factor and simplify. Factor. So first we want to look for anything that's in both terms. So I see there's an e to the x right there. So I can factor out that e to the x. There's a 3x plus 1 left over, minus 2, and there's a 5x left over, but this e to the x has been factored out to the front. Now I can simplify what's in here. This is e to the x, 3x plus 1 minus 10x. 3x minus 10x is negative 7x plus 1. Again, that's the form that you're typically going to see on multiple choice answers. We can also do some factoring and simplifying. With something that looks like this. Notice how there's an x plus 1 here and an x plus 1 here. Just as if this was y squared and this was y, we'd be able to factor out a y. If we've got an x plus 1 squared here and an x plus 1 here, we can factor out an x plus 1. And then in terms of what's left over, well, right here we had an x plus 1 squared. We took out one of them, but we still have an x plus 1 left. Still have a 7x plus 5 left. We factored out this x plus 1. And so we just have a sine x left out over here. Now this is something that we can easily multiply using the box. It might very well be that you run into an answer choice that actually looks exactly like this, or you could run into one that looks like this. Let's just go all the way through just so that you have the extra practice with it. Typically once we hit this, where we've got 1, 2, 3, 4 terms here multiplied by 2 terms over here, that gets long enough and messy enough and complicated enough that we typically aren't going to do a box and multiply it all out, even though we could. But typically if you just have two binomials, two little two-term expressions in parentheses, typically we will multiply those out, particularly if it's something like this up here where it's going to then end up simplifying a little bit more. Okay, the final thing that we're looking at are logarithms. So let's write logarithm rules. A couple of key things to remember. They like to come up in kind of odd places. Log a of x and a to the x are inverses, meaning they undo each other. Especially watch out for this with ln x and e to the x. So ln x is log base e of x, e to the x obviously is e to the x. So natural log of x and e to the x are inverses. They undo each other. So that means if we have something like this, these undo each other and pop out to be 3x. If we have something like this, e to the power of ln undo each other, that's x squared. It also works if we just have a logarithm with a different base. So let's say we had log base 2 of 2 to the 5x. Those undo each other, that's just 5x. Say we had 3 to the log base 3 of 7x minus 1. 3 and log base 3 undo each other, that's just 7x minus 1. Also remember the log rules. Log a plus log b turns into multiplication. Log a minus log b becomes division. And then multiplication, so let's say we have p times log of a becomes an exponent. Log of a to the p power. So that means if you have a problem like this, as a single logarithm, first thing you're going to do is you're going to use this rule. Then you're going to use this rule where addition becomes multiplication. And then we can simplify that a little bit further. And there we go. Okay, those are the basic algebra rules that you need in order to do the derivatives. So make sure you practice a bunch with those. Make sure you've got them all memorized. And this is the end of Derivatives 1 notes.